We are STAR, a student rocketry team from Madrid, Spain.
We decided to use Altair, specifically the Inspire software, to develop one of the most important pieces in our rocket, the motor retainer system.
The retainer must transfer the thrust to the rest of the rocket and be able to restrain the motor in other load scenarios, such as the parachute deployment. Since Inspire integrates structural simulation and topological optimization, we thought it would be an ideal tool for our case.
Due to safety reasons, the retaining system uses redundancy. As such, two parts will be optimized to obtain the best strength-to-weight ratio, and then combined in a final assembly that will also be simulated within the software.
The software has been used to guide and influence the design, but never to entirely replace engineering judgment. As such, several iterations of each retainer were studied to obtain the best solution.
Starting with the upper retainer, it has to transfer the load from the thrust of the rocket into the main fuselage. In addition, it has to hold the parachute, causing a load in the opposite direction. Finally, it will do this using three supports, three grounded screws with modified shear and axial strength. Following a circular symmetry, we start the iteration. With the previous iterations guiding the design, the final part was recreated in a CAD software. This lets us have more versatility, being able to change the thickness, height, etc. In addition, three extra supports were added for threaded rods. The final design has the following appearance.
The lower retainer has to transfer the loads from the bottom of the motor case into the main fuselage. Its main difference is its contact point. It's a ring to transfer the loads axially that are less damaging for the carbon fiber. It has three screws to hold it in place, and a final three screws needed for assembly reasons that aren't included in the simulation. After several iterations, the final design looks like this. Once the final assembly had been created in a CAD software, it was imported into Inspire to validate the design and make the final simulation. The final design includes three threaded rods and two centering rings to maintain the design in place. It also includes several more bolts that are useful for load transferring.
The best material combination was studied under normal operating conditions, deciding the difference between using aluminum 2024 or stainless steel 316. From this table, one can observe that using aluminum is always beneficial, as it increases the strength-to-weight ratio. Using all aluminum is the theoretical best. However, we chose the second column because it has a significantly higher safety margin.
Finally, four load cases have been considered. Two extreme conditions in which one retainer has been removed, so all the thrust is transferred to only one retainer. Even though the low safety factors may seem concerning, they are in localized stress concentrators, such as the screws, so it doesn't suppose a real threat.
Here we can see the prototype printed in PLA. It is very robust and lightweight. As such, we can conclude that the optimization was a success and is ready for manufacturing.
Thanks to Altair Inspire, the process was easy and dynamic. The program allows us an easy transfer between the model and our CAD program.
From start, we are very grateful and we know that we will keep using this software in the future.
See you in space!